So, as we know, all the aircraft parts and systems come under an ATA. The fuselage comes under an ATA, might be 53. The pylons come under an ATA, 54. The wings come under an ATA, 57. The horizontal stabilizer, all of these come under ATAs. Okay, so that we can classify them, we can identify them, and you'll find that all these, although they're mainly described in training manuals, the actual repair or maintenance for these is the structural repair manual, because we're invariably repairing damages on these, or chapter 20, which is the standard practices of the AMM, which deals in all of the standard practices of how to clean the wing, how to paint the wing, how to do standard practices for all the chapters from 51 to 50, from 53 to 57, excluding windows and doors. Okay. So the dimensions give locations on the fuselage. The scale for each dimension is in inches. Okay. We use these dimensions to find the components on the fuselage, and we always try to imagine that we are trying to describe an exact location of damage, let's say, on the phone, okay, to someone. So we need to be able to give the person a three-dimensional location, okay, using station lines in the fore and aft axis. Buttock line is in the left and right axis, and the water line is in the up and down axis. All right, this would give you a three-dimensional location in abstract of any location on the aircraft. Okay, if you ever saw the SRM, you'd see the stations are a favorite, because then we can find the exact location on the, let's say, the skin, that's where the damage was, where down the fuselage that damage is. Okay, note that station, what should be 0, is 130 inches forward of the nose, the tip of the radome. So it starts at 130 inches, or station 130 is the first one here visible where you can perform maintenance on. Okay, lots of people say, well, why did they do that? Probably because on the test aircraft, the initial 737 had a 130-inch probe on it to measure stuff for whatever reason. And therefore, when they removed the test probe, which was the tip of that was 0, it started the actual aircraft, the production line aircraft started at station 130. And we have the same for the wing, but with two reference dimensions. These reference dimensions give the wing locations in inches, okay, which measure in inches from the buttock line. Okay, so we have wing stations, okay, in inches from inboard to, or from buttock line to outboard, or wing buttock line from the fuselage buttock line to the wing buttock line, sorry. So stations and wing buttock lines. Vertical stabilizer has 4 reference dimensions. The vertical stabilizer station, the vertical stabilizer leading edge station, the rudder station, and the vertical stabilizer waterline. All of these, we got these water lines and stations because we have a perpendicular reference as one reference, and the other one is at an angle. And as we know from our basic Pythagoras theory, that a right angle line will always be shorter than the same line joining both ends, yeah, if it's at an angle, because that one will be longer through the ABC right angle triangle theory. Okay, that's why we need two references. One reference for the angled bit and one reference for the straight bit from the horizontal, from the zero waterline. The same thing happens for the horizontal stabilizer. Okay, the horizontal stabilizer reference dimensions are the stabilizer station, the stabilizer leading edge station, and the elevator station. Here we classify the structures in terms of primary structures and secondary structures. Okay, and you can see they're all indicated, color-coded. The primary structure transmits ground, flight, and pressure loads. In other words, the primary structures are integral to the, they are integral to the aircraft's structural stability, let's say. Okay. Whereas the secondary structure transmit air and inertial loads. Okay, they're used more for they're not used so much for structural rigidity of the aircraft, but more for aerodynamic smoothing, yeah, and enabling the smooth airflow. Okay, through when the aircraft's traveling at 900 kilometers an hour. Other equipment is the non-metallic parts, usually plastic or carbon constructor. Okay, you can see all these different materials. Example, dorsal fin. This is the dorsal fin. This connects. So this is a white piece, so the color of the paper. So this is metallic, but the dorsal fin, the attachment to it, is fiberglass. So all the purple bits, or magenta, if you want to call them that, are fiberglass. All the light gray parts are carbon fiber reinforced plastic. All the black parts are glass fiber reinforced plastics. And all the amber or yellow, whatever you want to call that, are glass fiber and carbon fiber reinforced plastic honeycomb sandwich. Probably can't see any externally because it will be inside the cabin. The floor, for example, the floor is sandwich reinforced melamine boards with the honeycomb sandwich within a honeycomb sandwich.